Welcome to part two of SQL Server Encryption Basics. And what I want to do here is walk you through a visual and help you to understand the different layers and pieces and parts of the whole SQL Server encryption hierarchy. What I'm going to show you is by no means the ultimate setup or the way that you would always use this. You're going to choose one or two of these and you can do pieces and parts and put them together. There's a lot of different ways to get to a secure encryption format, but I want you to understand the various terms, terminologies, and functionalities you're going to hear about and read about in documentation as we talk about moving through the various aspects of encryption later on in the course. Now, I want you to think about SQL Server as outside of SQL Server and inside of SQL Server. We can use functionalities outside SQL Server to store our keys, our passwords, those sorts of things. And as a matter of fact, anytime we use SQL Server encryption, we always start with basically a key that is generated at the Windows level outside SQL Server, and then that gets applied. Now we're back into kind of this whole structure of like a public key infrastructure, a PKI, but we want to start with one very strong password that gets applied to everything else, and it kind of sits at the top, and it kind of oversees things, if you will. Now that's outside SQL Server. Then within SQL Server, I want to talk about those encryption objects, the different pieces of functionality, the different keys, those sorts of things that we use within SQL Server to apply the encryption to our actual data. So notice in these three boxes here, the top one is clearly outside SQL Server, but the SQL Server encryption objects and the data are both within the confines of our SQL Server instance. Outside of SQL Server, this is where we would have an Enterprise Key Management Module, an EKM. Now, this stores keys outside SQL Server. So even if someone intrudes SQL Server, they can't poke around anywhere in there and find the actual encryption or decryption keys that they need to actually get at our encrypted data that's either at rest or in transit. Then there's password. We can store passwords that are used to encrypt data outside of SQL Server for the same reason. Then notice over here on the right side an LMK, a local master key. This is really the one that is generated at the Windows operating system level, totally separate from SQL Server, and it's used kind of as the basis for kicking off the encryption process. Now, when you get into SQL Server encryption objects, notice that within the SQL Server environment, we have asymmetric keys that can be created and used. We have database master keys that exist at the database level. We have symmetric keys. We're going to talk a little later on in the course about the difference between symmetric and asymmetric. We have a service master key. And then, of course, we have certificates, and we can generate our own certificates with an Active Directory certificate server. We can then have these certificates signed by the recognized authorities out there, the certificate agencies, that we can pay them some money to validate our credentials and give us basically a certificate that will sign ours, and it's recognized everywhere. And then, of course, there at the bottom is the actual data that we're trying to encrypt and protect. Now, the first thing you're going to notice is this EKM. This stores our asymmetric and symmetric keys. So when we need to do something in SQL Server that has to do with encrypting or decrypting data using an asymmetric or a symmetric key, then we're going to consult the EKM. We will reach outside. We will provide some sort of authentication, some secure environment to the EKM, and we will retrieve the keys that we need to access our data. Then we can store passwords outside of SQL Server. Now notice, I'm going to let all of these arrows kind of stack on top of each other. Notice they're different colors because I want you to see kind of this confusing web of utilizations of these various objects. And then I'll separate them out and go one more time. But this is why it gets kind of confusing when you look at it applying encryption out there in documentation. And one minute they're talking about a local master key and an EKM and an asymmetric key. And then in other places we're talking about symmetric keys and database masters and service masters. So let's just look at the relationship here. So if we just store a password outside SQL Server, we can use that password to encrypt and protect our asymmetric key, our database master key, the symmetric key, the certificate itself, and then notice we can even use that password to directly protect our SQL Server data. But again, this password is stored outside SQL Server. Even if the 13-year-old next door manages to intrude our SQL server, they can't get either our asymmetric or symmetric keys. They're stored in EKM outside of SQL Server, and they can't get the password that we're using. It is also stored outside SQL Server. The local master key also originates from outside SQL Server. It is used to help generate the service master key. Now, the service master key is kind of the top of the hierarchy for the keys within SQL Server. And then the service master key is used to encrypt the data master key. Think about this obstacle course of multiple levels of encryption being applied. First, we start off up here with an LMK. We use that to encrypt the service master key that's generated within SQL Server. We use the service master key to encrypt the database master key that is then used to encrypt our asymmetric key and a certificate. Okay, so we're just kind of building layer after layer of encrypted pieces of information to make it very, very unlikely that you're going to be able to basically compromise all of these levels in this obstacle course and get through it. And then, of course, we can use our asymmetric key, our symmetric key, and our certificate to encrypt or decrypt the actual data down at the storage level for our data that's at rest or in transit. You may want to just kind of freeze the video here, take a picture of this, just kind of hang on to it. But this is going to be one scenario of relationships between these various SQL Server encryption objects, the things that we can store outside SQL Server, and how we actually get down to the data level with this. Let's take it one at a time so you can see these separately. Remember the EKM, the Enterprise Key Management Module? This stores asymmetric and symmetric keys, SQL Server encryption objects, but it stores them off-site, outside of SQL Server to protect us from intrusions. Then those asymmetric keys and symmetric keys can be used to encrypt and decrypt our SQL Server data. From the password being stored outside of SQL Server, we can use this password to encrypt our asymmetric key, our database master key, our symmetric key, our certificate, and even the data itself directly. And we can also use the symmetric, asymmetric, and certificates to encrypt and decrypt our data. Finally, we'll finish this up with the local master key. The local master key gets generated when we install SQL Server by the Windows operating system. That encrypts the service master key. That's used to encrypt the database master key. And then that can be applied to, for example, asymmetric keys or certificates, and then those can be used to directly encrypt and decrypt data. There is one aspect of this that we're going to talk about later on, because encryption can really quickly start to sound like that silver bullet that I talked about in part one. Now we've got our data absolutely protected. What could possibly go wrong? As it turns out, there is a dark side of encryption. We'll talk about that later in a separate video. But for now, I hope this helps you understand the relationship of these various SQL encryption objects that you're going to bump into as we talk about implementing and utilizing encryption in various places in SQL Server.